Hey time travelers, it seems like the Panopto videos aren't loading, so in case of emergency, I'm just gonna run through the problems. I'd recommend for any of these like solve through videos that you take a jab at it first, and then you can run through the video to make sure you didn't like do it wrong. Instead of just watching me solve it. That's just always gonna be my recommendation. So Susan is driving north at 60 miles per hour, and Trent is driving east at 45 miles per hour, and they are approaching an intersection. What is Trent's speed relative to Susan's reference frame? Okay, so we are given that, let's draw out a diagram. We're given that Trent is driving east at 45 miles per hour, and Susan is driving north at 60 miles per hour. And we are saying that she's going to be the reference frame. So if she's the reference frame, now Trent's like velocity vectors is going to be that same 45 miles per hour in the east direction and negative 60 in the north direction, i.e. 60 miles per hour going south. So I'm just gonna say S hat. And then I can say this is east hat. And we're asked for the speed relative to Susan's reference frame. And so we're going to say this is the velocity vector because it's the two components added together. So we can say that it's going to be velocity is equal to all of the components together square rooted.
So we have 45 miles per hour squared, 60 miles per hour squared, and take the square root of that. And we get
75 miles per hour. And this is a speed. So we are actually not going to put a vector on it. I know that in really picky people, if I just put vector or if I put velocity without putting the little vector hat on it, like this, then that counts as speed. But I, for being careful, would just write out speed. Or you could just say magnitude. And magnitude will always mean speed. Magnitude of velocity. This one's pretty simple. Or at least calculations wise, it's pretty simple. You just need to know sort of what's going on with the vectors.